Every river on Earth right now is flowing toward the sea. Every single one. And not one of them has ever stopped. Not in 10,000 years. Not in a million. The river outside the nearest town to where you are lying tonight have been flowing since before the first human ever stood beside it. And tonight, we are going in. Hello there and welcome to the Sleepy Science Facts channel. Tonight we will be drifting into the world of rivers. Not simply the water moving between two banks, and not just the famous ones you have seen on maps. We are going into all of it. The science of how a river begins from a single drop of rain on a hillside and becomes something wide enough to lose a city in. The mystery of rivers that flow underground for hundreds of kilometers without ever seeing the sky. The ancient rivers that carved landscapes so vast that their valleys are now filled with other rivers entirely. The rivers that built the civilizations we still live inside the ruins of. The rivers that run backward, that flow uphill in ways that seem impossible, that disappear into deserts and never reach the sea. Rivers cover less than 1% of the Earth's surface, yet they carry all the planet's fresh surface water to the ocean, carve the most dramatic landscapes on land, support the greatest concentrations of biodiversity in the terrestrial world, and have determined the location of almost every major city, empire, and agricultural civilization in human history. They are among the most studied features of the natural world and among the least understood in their full complexity. After centuries of exploration and scientific investigation, rivers continue to reveal new behaviors, new histories, and new connections that researchers had not thought to look for. From the longest river on Earth to the shortest, from the clearest mountain stream to the sediment-heavy delta where a great river finally meets the sea, rivers reward curiosity with something genuinely extraordinary at every bend. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Let your body soften and allow your breathing to slow and allow the day to gently fade away as we explore the mysteries of rivers together. Let's begin. A river begins before it has a name, before it has a channel, before it is recognizable as a river at all. It begins as rainfall or snow melt on a hillside, moving across the surface as a thin sheet of water too shallow to see from a distance. This sheet flow is unstable. Tiny irregularities in the ground surface concentrate the water into threads, and those threads cut slightly deeper into the soil, concentrating more flow, cutting deeper still, in a feedback that very quickly produces a definite channel. This process, called rill formation, happens on virtually any slope receiving enough rainfall, and it is the first step in the birth of a river. Once a channel exists, it captures more flow, erodes more deeply, and begins to carve its path through the landscape in a way that becomes self-reinforcing over time. The river grows by capturing the drainage of surrounding slopes, by cutting headward into the hills above it, and by receiving the flow of tributaries that are themselves growing by the same process. A great river is not a single feature but a network, a branching tree of channels that may collect rainfall from an area of millions of square kilometers and concentrate it into a single trunk stream that carries all of it to the sea. The Amazon basin drains approximately 7 million square kilometers, roughly the area of Australia, and funnels it into a single river that discharges more fresh water into the ocean than the next 7 largest rivers combined. The river you see on the surface is a final expression of a catchment that gathers water from an area so vast it contains climates, ecosystems, and landscapes of every imaginable variety. The Amazon River is the largest river on Earth by water volume, and its scale defies ordinary comprehension. At its mouth, the Amazon discharges approximately 209,000 cubic meters of water per second into the Atlantic Ocean, a flow so enormous that it dilutes the salinity of the ocean for over 200 kilometers offshore. The river is so wide at its lower reaches that you cannot see from one bank to the other, and during the annual flood season, when the river rises by as much as 14 meters, it spreads across an area of floodplain the size of a small country, inundating forests that remain underwater for months. Fish swim through the treetops. River dolphins navigate between flooded tree trunks. Entire ecosystems exist in the transition between the river and the forest, neither fully aquatic nor fully terrestrial, designed for a world that is sometimes one and sometimes the other. The Amazon has no significant delta in the conventional sense, because the enormous volume of water it discharges prevents sediment from accumulating at the mouth. Instead, the river punches straight into the Atlantic, a freshwater jet that can be detected by satellites as a plume of different colored water extending far into the ocean. The river contains more species of fish than any other river system on Earth, with over 3,000 species described, and researchers estimating that many more remain undiscovered. In the flooded forests of the Amazon basin, the boundaries between the river and the land, between the aquatic and the terrestrial world, are not fixed lines but seasonal gradients that the entire ecosystem has organized itself around for millions of years. Let your breathing slow just a little. There is no hurry tonight. The river moves at its own pace, and we will move with it. The Nile was long considered the longest river on Earth, and the debate over whether it or the Amazon deserved that title is one of the most technically complex disputes in geography. The difficulty lies in defining where a river begins. A river's length depends entirely on which source you designate as its origin, and for rivers with complex drainage networks, there may be multiple tributaries that are equally valid candidates for the title of main channel. For most of the 20th century, the Nile was listed as the world's longest river at approximately 6,650 kilometers. Then a series of studies in the 1990s and 2000s, using GPS and satellite mapping to measure previously inaccessible headwater tributaries of the Amazon, suggested that the Amazon's most distant source, a glacial stream called the Mantaro in the Peruvian Andes, would make the Amazon slightly longer if included. The question has not been definitively settled, and different sources still list different rivers as the longest. What is not disputed is the cultural and historical significance of the Nile. It flows through the most arid region on Earth for most of its length, passing through the Sahara Desert for thousands of kilometers, a green ribbon of life in a landscape that receives almost no rainfall. The entire agricultural wealth of ancient Egypt depended on the annual Nile flood, which deposited a layer of nutrient-rich silt across the floodplain every year, restoring the fertility that the previous year's crops had removed. The Nile did not simply support Egyptian civilization. In a region that would otherwise be uninhabitable desert, it created the conditions for civilization to exist at all. Rivers do not simply flow in straight lines from high ground to the sea. They meander, and the process of meandering is one of the most beautiful and least intuitive in all of geomorphology. A river flowing across a flat floodplain will inevitably develop curves, and once those curves form, the physics of flowing water causes them to grow. On the outside of each curve, the water flows faster, eroding the bank and cutting it back. On the inside of the curve, the water flows more slowly, depositing sediment and building a gentle slope called a point bar. This erosion on the outside and deposition on the inside causes the curves to migrate across the floodplain over time, sweeping slowly back and forth in loops that can move meters per year. As the curves grow larger, they eventually become so pronounced that the necks between adjacent loops become very narrow. During a flood, the river may break through the narrow neck and take the shorter, straighter path, abandoning the long loop it had been flowing through. The abandoned loop, cut off from the main channel, becomes a crescent-shaped lake called an oxbow lake, sitting beside the river that formed it, gradually filling with sediment and vegetation as the river moves on. The Mississippi River has thousands of oxbow lakes scattered across its floodplain, each one a record of a curve the river once followed and eventually abandoned. A river's floodplain is not flat, empty ground. It is the accumulated history of every path the river has ever taken, written in soil and water across the landscape. Underground rivers flow through cave systems beneath the surface of the earth, sometimes for hundreds of kilometers, in a world of total darkness that most people never consider when they think about rivers. In karst landscapes, where slightly acidic water has dissolved the limestone bedrock over thousands to millions of years, surface drainage often disappears entirely into the ground through sinkholes, flowing through cavern networks before re-emerging at springs sometimes far from where it entered. The Puerto Princesa subterranean river in the Philippines flows through an enormous cave system for about 8 kilometers before emptying directly into the sea, and its accessible section has been a UNESCO World Heritage Site since 1999. In Slovenia, the Reka River disappears into the Skokjen Caves, drops through a dramatic underground canyon, and eventually re-emerges as a Tamavo River in Italy, having traveled approximately 34 kilometers underground. The world's longest known underground river is in Mexico's Yucatan Peninsula, where a system of flooded caves called cenotes connects underwater channels extending for hundreds of kilometers beneath the jungle. These underground rivers carry enormous volumes of water and are the primary freshwater source for the Yucatan, but they are also extraordinarily vulnerable to contamination because the same limestone that creates that channel provides no filtration, meaning pollutants enter the groundwater directly and spread through the cave system without the purification that surface soils provide. The underground river is invisible silent, and essential, and in many parts of the world it is less understood and less protected than the rivers that run in the open air above it. Now, let the weight of the blanket settle around you. Let your eyes stay closed. The river we are following tonight has no hurry, and neither do you. The Colorado River carved the Grand Canyon over a period of approximately 5 to 6 million years, and the canyon it created is one of the most dramatic geological archives on Earth. The Grand Canyon is approximately 446 kilometers long, up to 29 kilometers wide, and over 1,800 meters deep at its deepest point. The rocks exposed in its walls span approximately 2 billion years of geological history, from ancient Precambrian basement rocks at the bottom to relatively young Permian sedimentary layers at the rim. Walking down into the canyon is walking back through time, with each distinct rock layer representing a different environment and era. Limestone layers formed from ancient seafloors. Sandstone layers formed from desert dunes. Shale layers formed from river deltas and shallow marine environments. The canyon is not just a record of the Colorado River's erosive power. It is a cross-section through a large fraction of Earth's history, exposed at a scale and with a clarity that has made it one of the most studied geological sites on the planet. The Colorado River that carved the canyon no longer reaches the sea. It has been so heavily diverted for agriculture and urban water supply that it now typically runs dry before reaching its mouth in the Gulf of California, a river so profoundly altered by human use that it cannot complete the journey it has been making for millions of years. The canyon it carved is permanent. The river that carved it has, in a very real sense, been consumed. Rivers carry not just water but an enormous quantity of sediment, and the way they move and deposit the sediment shapes the landscape of entire continents. When a river flows fast, it can carry large particles in suspension and along the riverbed, rolling and bouncing boulders, gravel, and sand downstream. When it slows, the heaviest particles settle first, followed progressively by lighter ones as the velocity decreases. This selective deposition sorts sediment by size and a predictable pattern from coarser particles near the channel to finer particles farther from it, and it is a process that builds river deltas, alluvial fans, and floodplain soils. The Ganges and Brahmaputra rivers together carry approximately 1 billion tons of sediment from the Himalayas to the Bay of Bengal every year, building the Ganges-Brahmaputra Delta, the largest delta on Earth and the home of approximately 170 million people in Bangladesh and West Bengal. This delta is made entirely of material removed from the Himalayan mountains by erosion and carried to the sea by rivers, grain by grain over millions of years. The soil that feeds hundreds of millions of people is ancient mountain, delivered by water. The same process is happening on every continent. The rich agricultural soils of the Mississippi Valley, the Nile Delta, the Mekong Delta, and the great river plains of China are all gifts from distant mountains, transported by rivers that have been working as geological delivery systems since long before any human recognized the debt. The Mississippi River and its tributaries form the third largest drainage basin in the world, collecting water from 31 American states and 2 Canadian provinces and funneling it into the Gulf of Mexico. At its mouth, the river discharges an average of 16,800 cubic meters of water per second, but during major floods this can increase dramatically, with a great flood of 1927 delivering flows that inundated an area of over 65,000 square kilometers across 7 states, displacing approximately 700,000 people and reshaping both the physical and political landscape of the American South. The Mississippi has been straightened, leveed, dredged, and channeled to such an extent that it now flows considerably faster than it would naturally and carries its sediment load all the way to the Gulf rather than depositing on the floodplain, which is causing the Louisiana coastline to sink and erode at alarming rates because it is no longer receiving the sediment needed to maintain its elevation. The delta land that was built over thousands of years by sediment deposition is disappearing within decades because the river has been prevented from doing what it has always done. The conflict between the river's natural tendency to flood, meander, and deposit sediment and the human need to control it for navigation, agriculture, and flood protection is one of the most enduring and consequential engineering challenges in American history, and it has no permanent solution. Only a constantly renegotiated balance between natural processes and human infrastructure. Rest here for a moment. Let your muscles go soft. Let your thoughts follow the current wherever it takes them. You do not need to hold on to anything. The rivers of the world support a biological diversity out of all proportion to the small fraction of the Earth's surface they occupy. Freshwater ecosystems, of which rivers are the most dynamic, cover less than 1% of the Earth's surface but contain approximately 10% of all described species and about a third of all vertebrate species. Rivers are the most species-rich freshwater habitats because they offer the greatest variety of physical conditions, from fast-flowing headwater streams with cold, oxygenated water to slow, warm lowland reaches with muddy beds, from deep main channels to shallow gravel bars, from the open water to the hyperhike zone. The region beneath and beside the riverbed where water percolates through gravel and supports its own community of specialized organisms. The Mekong River in Southeast Asia contains over 1,000 species of fish, including the Mekong giant catfish, one of the largest freshwater fish in the world, reaching lengths of 3 meters and weights of 300 kilograms. The Congo River, the deepest river in the world with measured depth of over 220 meters, contains species found nowhere else, adapted to the specific combination of depth, current, and water chemistry of particular reaches. The river dolphin, a group of freshwater cetaceans found in the Amazon, Ganges, Yangtze, and Orinoco rivers, represents the independent evolution of dolphin-like forms in freshwater environments, a remarkable convergence between river-dwelling and marine mammals that shared a common land-dwelling ancestor and then evolved along completely different paths in completely different worlds. The source of the Nile was one of the most fiercely debated geographical questions of the 19th century, and the expeditions mounted to find it produced some of the most dramatic and consequential journeys in the history of exploration. European geographers had known for centuries that the Nile flooded annually, filling Egypt with water and fertile silt. But the origin of that water in the distant interior of Africa was unknown to them. The expeditions of John Speke, Richard Burton, David Livingstone, and Henry Stanley in the 1850s through 1880s to discover the Nile source were among the defining adventures of the Victorian era, producing maps, natural history collections, geographical knowledge, and colonial contacts that shaped the subsequent history of an entire continent. Speke claimed Lake Victoria as the source of the Nile in 1858, a claim that was disputed and contested for decades. The modern answer is more complex than any single lake. The White Nile, which drains Lake Victoria and flows northward through Uganda and Sudan, provides the Nile's flow during the dry season. The Blue Nile, which originates in the Ethiopian highlands at Lake Tana, provides approximately 85% of the total annual flow and virtually all of the floodwaters that made ancient Egyptian agriculture possible. The Nile of the Pharaohs was the Blue Nile, fed by the monsoon rains falling on mountains 2,000 kilometers to the south, carrying the fertility of the Ethiopian highlands to the delta in a gift the Egyptians celebrated annually but never fully understood. Rivers freeze from the surface downward, and the ice that forms on them behaves in ways that are both dangerous and astonishing. When air temperature drops below freezing, a river loses heat to the atmosphere from its surface, and the surface water cools until it freezes. Ice forms first along the shallower margins where the water is slowest, and then spreads toward the center of the channel. But rivers also form a type of ice called frazzled ice, tiny spicular ice crystals that form throughout the water column in turbulent sections where the water is supercooled. Frazzled ice is sticky, attaching to any surface it contacts, including the undersides of anchor ice on the riverbed, the gratings of water intakes, and the hulls of boats. When frazzled ice accumulates and forms an ice jam, it can back water up dramatically, causing floods far more sudden and damaging than ordinary river floods. The spring breakup of river ice in northern rivers is one of the most powerful and dangerous events in those landscapes, as the ice cover, sometimes over a meter thick, begins to move downstream in massive sheets and blocks that can demolish bridges, gouge riverbanks, and pile into jams that can raise water level by 10 meters or more within hours. The Yukon River breakup in Alaska has been watched and bet on since the late 19th century, with residents recording the exact time and date of the ice breakup each spring in a tradition that has produced one of the longest continuous environmental dataset of any natural phenomenon in North America. There is something very settling about water that moves steadily and without urgency. Let that thought carry you a little deeper into the quiet. The river does not rush. It simply continues. Some rivers run uphill, at least in appearance, and the geological explanations for these reversals of drainage are among the most dramatic stories in the history of the landscape. The Finca River in Central Australia is believed to be one of the oldest rivers on Earth, with a course that has remained largely unchanged for over 300 million years, predating even the breakup of the ancient supercontinent Gondwana. Many rivers in Africa flow in directions that seem counterintuitive relative to the current topography because they established their courses before the current topography existed, carving their valleys when the land was configured differently and then persisting in those courses as the land was subsequently deformed by tectonics. The Namdhar River in India flows westward to the Arabian Sea, while most rivers on the Indian peninsula flow eastward, because it occupies a tectonic rift valley that directed it westward before the Deccan Plateau reached its current elevation. The Yarlung Zangpo River in Tibet flows eastward along the highest plateau on Earth and then makes one of the sharpest turns of any river in the world, swinging south and cutting through the Himalayas in a gorge 5,000 meters deep, because the river established its course before the Himalayas rose around it and has been cutting downward as fast as the mountains have risen, maintaining its path through sheer erosive persistence. These antecedent rivers are rivers that refuse to be rerouted by mountains, that kept cutting while the land rose around them, and whose courses record a drainage pattern that predates the landscape they now flow through. The role of rivers in the development of human civilization cannot be overstated, and every major early civilization arose in a river valley for reasons that are both obvious and profound. The Tigris and Euphrates rivers in Mesopotamia, the Nile in Egypt, the Indus in South Asia, the Yellow River in China, and the Niger in West Africa each provided the same essential combination of flat, fertile floodplain soil regularly renewed by flood deposits, abundant fresh water for drinking and irrigation, and navigable waterways for trade and communication that allowed dense populations to concentrate, specialize economically, and develop the administrative complexity that characterizes civilized societies. The hydraulic management required to exploit these rivers fully, the building of irrigation canals, the coordination of water allocation, the construction of flood defenses, may itself have been a driver of social complexity, requiring the cooperative organization of large numbers of people under centralized authority in ways that simpler rainfall agriculture did not demand. The Yellow River in China, sometimes called China's Sorrow because of its catastrophic flood history, has also been called the cradle of Chinese civilization, and both names reflect the same reality. The river that gave enough to sustain a civilization also, periodically, took everything back. The management of its floods has been a central preoccupation of Chinese governance for at least 4,000 years. The history of China and the history of its management of its rivers are, in many periods, the same history. Some of the most extraordinary rivers on Earth are not rivers of water at all. Lava rivers flow from active volcanoes at temperatures of around 1,000 to 1,200 degrees Celsius, following the same topographic laws as water rivers, pooling in low points, channeling through valleys, and eventually cooling and solidifying into rock. But there are also rivers of cold, dense air called katabatic winds that flow down mountain slopes like invisible water, rivers of sand that flow slowly through desert systems following wind and gravity, and rivers of ice in the form of glacier that flow imperceptibly slowly but with enough force to carve valleys hundreds of meters deep. The deep ocean has rivers too, bottom current of cold, saline, dense water that flow along the ocean floor for thousands of kilometers, following submarine valleys and topographic lows away surface rivers follow valleys above. These thermohaline currents are driven by differences in water density rather than gravity relative to the land's surface, but their behavior, their channeling, their meanders, and their deposition of sediment mirrors surface river behavior in ways that have fascinated oceanographers. The concept of the river, water following topography from high to low, seems to express something so fundamental about the way fluids move in the presence of gravity that it reproduces itself at every scale, and in every medium where the conditions are right. The color of a river tells a story about its watershed, its geology, and its health. The Rio Negro in Brazil, one of the Amazon's largest tributaries, is the color of dark tea, stained by tannins and other organic acids leaching from the decomposing vegetation of the flooded forest it drains. Where the dark Rio Negro meets the pale, sediment-laden Solomos River at Manaus, the two rivers flow side by side for approximately 100 kilometers without mixing, a phenomenon called a meeting of the waters, produced by differences in water temperature, density, and current speed that prevent the two streams from blending despite flowing in the same direction and in contact with each other. The Blue Nile carries a reddish-brown silt that made it Egypt's agricultural lifeline, and its color changes dramatically with the seasons, running nearly clear in the dry season and thick with silt during the Ethiopian monsoon. Glacial rivers are often milky gray or greenish blue, colored by rock flour, the fine powder produced when glacier grind rock against rock at the base of the ice. The Green River in Wyoming gets its name from the algae that color it in certain seasons. The Rio Cono crystals in Colombia turns red, yellow, pink, and green in its spectacular dry season display, colored by aquatic plants that can only show their pigments when the water is shallow and clear. The color of a river is not decoration. It is information, a visible record of where the water has been and what it has carried on its way to where it is now. Lay back a little further. Let the sounds of the night settle. The river we have been following tonight has carried us a long way, and there is still more to see. But you can rest while we travel. That is the whole point. The fish that return from the ocean to spawn in the rivers where they were born perform one of the most physiologically extraordinary journeys in the animal kingdom, and the transformation they undergo to make it possible is no less remarkable. Pacific salmon hatch in freshwater rivers, spend the early part of their lives in the river, migrate to the ocean where they grow to maturity over several years, and then return to the precise river, and often precise tributary, where they hatch, guided by a chemical memory of the specific mineral and biological signature of their birth water. The return journey can involve swimming hundreds of kilometers upstream, leaping waterfalls, fighting strong currents, and navigating complex river networks, all while the fish undergoes dramatic physical transformation. Its digestive system shuts down. Its body begins consuming its own muscle and organ tissue for fuel. Its jaw reshapes. Its skin color changes. In Pacific salmon species, the fish die after spawning, and their decomposing bodies fertilize the river with marine nutrients, including nitrogen and phosphorus that were removed from the watershed by the ocean food chain, and are now being returned by the salmon. The bays, eagles, wolves, and other animals that eat salmon carry these marine nutrients deep into the forest, and studies have traced marine nitrogen from salmon carcasses into the wood of trees growing hundreds of meters from the riverbank. The river and the ocean are connected not just by water flowing one direction, but by salmon carrying the chemistry of the sea back to the mountains. River deltas are among the most productive and most threatened ecosystems on Earth, and the forces that maintain them are in many cases being actively disrupted by the same human activities that depend on them. A river delta forms where a river meets a relatively calm body of water, and its velocity drops so suddenly that it can no longer carry its sediment load. The sediment falls out of suspension and accumulates, building the characteristic fan-shaped landform of multiple branching channels spreading across flat ground that is just barely above sea level. The Nile Delta, the Mekong Delta, the Mississippi Delta, the Rhine-Maas Delta, and the Ganges-Brahmaputra Delta together support populations totaling hundreds of millions of people, and their extraordinary agricultural productivity is a direct product of the regular sediment renewal that rivers once provided. But dams built upstream trap sediment that would otherwise reach the delta, and the land that no longer receives its annual renewal of silt begins to compact and sink. Combined with sea level rise, the result is that many of the world's most densely populated river deltas are slowly submerging. The Nile Delta has been losing land to the Mediterranean since the construction of the Aswan High Dam in the 1960s reduced the sediment reaching it by more than 98%. The city of Alexandria, built on the delta's edge, faces a future in which the land it stands on is sinking while the water around it is rising, a double threat created by the same river management choices that brought electricity and flood control to millions of people upstream. The longest river in Europe is the Volga, which flows approximately 3,690 kilometers from the Valdai Hills northwest of Moscow to the Caspian Sea, draining about one-third of European Russia. The Volga has no outlet to the world ocean because the Caspian Sea is landlocked, making it in geological terms an endorheic basin, a drainage system that collects water without releasing it to the sea. The Volga has been the backbone of Russian history and commerce for millennia, providing the transportation corridor along which trade, settlement, and conflict have moved from the Baltic to the steppe for as long as Slavic peoples have inhabited the region. The river's name in Russian is associated with water in a way that reflects how fundamental it has been to the culture and economy of the people who live along it. During the Second World War, the Battle of Stalingrad was fought on its western bank, and the river's width and current were critical factors in the logistics of the battle, with Soviet forces holding a strip of the western bank so narrow they could be supplied only by night crossings under fire. The Volga runs through 18 of Russia's largest cities, produces nearly half of Russia's agricultural output in the regions it irrigates, and is so thoroughly modified by dams and reservoirs that its flow is now almost entirely regulated by human infrastructure. The river that made Russia is now managed by Russia in an almost total reversal of the dependency that existed for most of history. The water in a river is almost never simply water. It is a solution of dissolved minerals, gases, and organic compounds, a suspension of fine particles, and a living environment for billions of microorganisms, all of which contribute to its chemistry and its character. The hardness of water, the property that causes scale in kettles and interact with soap, reflects the concentration of calcium and magnesium ions dissolved from the limestone and chalk that the river flows over. The conductivity of the water tells researchers something about the total concentration of dissolved ions and the general geology of the watershed. The oxygen content of the water determines which species of fish and invertebrate can survive in it, with cold, fast-flowing mountain streams containing more dissolved oxygen than warm, slow-flowing lowland rivers. The pH of river water affects the availability of nutrients and the toxicity of metals, with naturally acidic rivers in peat-covered catchments and artificially acidified rivers in regions affected by acid deposition supporting different biological communities from circumneutral rivers. The chemistry of a river is a running analytical record of everything that water has touched on its journey through the watershed, from the composition of the rocks it has flowed over to the agricultural chemicals applied to the fields it drains, from the decomposition products of the forests in its headwaters to the thermal pollution from the power stations on its lower reaches. River water is not a simple thing. It is a complex, dynamic chemical environment that changes with every kilometer of its course. The night is very deep now, and you have been traveling a long way. Let your body be completely still. Let the last of the day's tension release. There is nothing left to do tonight except rest. Rivers have inspired human creativity for as long as humans have been creative. The Ganges is sacred to over 1 billion Hindus, who consider its waters purifying and who have worshipped it as a goddess for thousands of years. The Nile was personalized as a god in ancient Egyptian religion, celebrated in hymns that describe it as a source of all life. The Yellow River in China is called the Mother River of Chinese civilization, and its flooding and management are threaded through thousands of years of Chinese literature, mythology, and history. The Rhine runs through the heart of European romantic literature and music, its dramatic gorge and castle-topped crags inspiring German romantic painters, Wagner's operas, and Heine's poetry. Mark Twain built his literary identity around the Mississippi, and his description of the river's moods, characters, and landscape defined a generation's understanding of the American interior. The rivers of the world are not simply geographical features. They are characters in the stories that human cultures have told about themselves, symbols of time, of change, of the continuity between the living and the dead, of the boundary between the known world and the unknown. Every culture that has lived beside a significant river has made that river a part of its inner life, finding in the ceaseless, patient flow of water a mirror for things that are difficult to say in any other way. And so we drift gently back from the rivers of the world, carried by the current to a quiet and easy place, carrying with us everything we found along the way. We watched the river begin as a thin sheet of water on a hillside, and followed it all the way to where it punches through the wall of the Atlantic Ocean, in a freshwater jet 200 kilometers wide. We followed the salmon from the sea back to the precise mountain stream where it hatched, guided by a memory written in chemistry that nothing is erased in 4 years of ocean wandering. We found rivers flowing underground through absolute darkness for hundreds of kilometers, and rivers on the ocean floor following submarine valleys and thermohaline currents that mirror the surface world above them. We stood at the meeting of the waters in Manaus and watched 2 rivers flow side by side without mixing, each one keeping its color and its character for 100 kilometers of shared channel. We followed the Colorado as it carved a canyon through 2 billion years of time, and watched the Nile deliver the Ethiopian highlands to Egypt one summer flood at a time. We found that the river heals a mind, that the sound of moving water is one of the oldest signals of safety that a human brain knows, and that the calm it produces is not simply pleasant but written into us by millions of years of living beside water. The rivers have been here since before the first human knelt to drink from one, and they will be here long after the last human name for them has been forgotten. They are patient and purposeful and continuous, and they ask nothing of you tonight except what you are already doing. Simply resting, simply breathing, simply letting the current carry you where it always goes. If you enjoyed this sleepy journey, you could support the channel by liking, subscribing, or leaving a calm little comment before you rest. It helps more curious minds find their way here. And if you are still awake, there's another video waiting on your screen, ready to carry you onward into another corner of science. But for now, let the questions loosen their grip. Let your shoulders soften. Let your jaw unclench. Allow your breathing to slow, steady, and deepen. Picture a river at night, moving quietly through a dark landscape, its surface catching the faintest light from the sky above it, its sound continuous and low and untroubled. The water that is passing this moment has been on a journey of hundreds of kilometers, and it has more hundreds ahead before it reaches the sea. It is not hurrying. It never hurries. It simply flows, steady and unhurried, in the dark, toward where it has always been going. Let yourself move the same way. Not hurrying, not holding, just flowing quietly toward the rest you have always needed. Sleep well, and good night.